Okay, let's move on to the operation example of the Smith chart. And I suppose you have the chart with you. And as you can see from your Smith chart, there are a lot of circles on it. If you look from the outside, the first circle is on the left hand side you have it's labeled as wavelengths toward generator. So it means that if you are moving from the low, from the termination to the generator, from the right hand side to the left hand side of the transmission line, then the point should move clockwise. And on that circle, the very left end is marked as 0.0. And as you can see, if you rotate clockwise, the number will increase. On the top is around 0.12, 0.13. On the right hand side, it's 0.25. So if you are moving on the Smith chart, half a circle equals to a quarter wavelength. A full circle equals to half wavelength, 0.5. So if you keep moving clockwise, you will see the number is getting larger and larger on that circle. So on the left hand side, it's increased up to 0.49, which will end up as 0.5 on the left hand side. If you're looking at the circle inside the outermost circle, it's labeled as wavelengths toward the low. So if you're moving from the left-hand side to the right-hand side of the transmission line, you should move counterclockwise on the Smith chart. On the Smith chart, counterclockwise will bring you from left to right. And now if you move into one next circle inside, you can see the label can be found on the right hand side. It's angle of reflection coefficient in degree. So as already told you, the Smith chart itself, the circular Smith chart itself is a map, it's a mapping, it's a transform from impedance, real and those circles and curves are real and imaginary part of the impedance. And the position on the Smith chart represent the magnitude and the phase of the reflection coefficient. So on the third circle, from the outside, it's labeled as angle of reflection coefficient in degrees. So if you move counterclockwise, it goes from 0 to 90 to 180 to, well, on the top half, it's labeled from 0 to 180. On the bottom half, it's labeled with 0 to minus 180. Okay, so it's a full circle, as you can imagine. And the next one is angle of transmission coefficient in degree, which we won't use that we won't discuss about that in this part of the course. Now, if you look at the bottom of the black magic design of the Smith chart, on the bottom, you see a couple of rulers, a couple of rulers. You will probably use a few of them, or you not necessarily need to use them, but as you can see, the one on the top left, 左上角哈, the one on the top left is marked as SWR. So as you can see, the ruler is not linear. It goes from 1, it actually goes from 1 to infinity. There are 2 places that you can find the corresponding SWR value. So you are highly recommended to bring a ruler during the final test. 期末考的时候记得要带尺哈，记得要带尺，比较好比对啦。One way to check up with the SWR value is so here's your Smith chart. Okay. Once you enter the reflection coefficient, for example, over here, you 也要带圆规，记得带圆规，没有吗？跟你妹妹借啊。没有妹妹啊，对不起。不好意思，我每年都要想要讲这个冷笑话。好，拿那个圆规哈，依照那个它对圆心的半径画一个圆，然后看这个圆，这个圆叫做 SWR circle 就是 circle is referred as SWR circle， and find the intersection of the SWR circle with respect to the real axis. On the right-hand side, find the number of the intersection. That will be your SWR number. Okay? So, as you can see, the real on this real axis, the label goes from 1 to 2, 3, 4, 5, blah blah blah, all the way up to infinity. And the other way to determine the SWR number is use the ruler to measure the length of this section, the length of this section, and check up with the ruler on the bottom of the Smith chart, and you will find the corresponding SWR with the SWR ruler. You will see that you can check up the ticks. Well, actually, this one is the same as the ticks on the Smith chart. The reason why is SWR is defined in terms of上面是加还是减？加 ，OK. All right. Okay, we will discuss a little bit more about that later. So on the Smith chart, you will find some ticks and circles and lines that will be useful when you perform operation on it. And today we will begin with an example. So you should hang on with your Smith chart and follow me on this procedure. So for example 7.4, a transmission line of characteristic impedance of 50 ohm is terminated by a low impedance ZR equals to 15 minus 20J ohm. So the resistance of the load is 15 ohm. The reactance is minus 20, which is capacitive or inductive? Capacitive. So it's desired to find the following quantity, and you can use Smith chart to accomplish this task. The first task is find the reflection coefficient at the low, which I label as gamma R. So what is the first thing that we should do? The first thing is to find the normalized impedance by taking the division of ZR over Z sub 0. So what is the normalized impedance of this load? 0.3 minus 0.4. Once you have the normalized impedance, you can enter the reflection coefficient using the circles on the Smith chart. So on the Smith chart, find out the circles, the real part of 0.3, which is this dashed line. Okay, can you find that? Can you find the complete circle? The complete circle represents the resistance 啊，可以找到全圆的实部是完整的圆，虚部是往上撇跟往下撇不完整的圆弧线啊，不是完整的圆啊。所以实部的话呢，就找完整的圆，然后找多少 0.3 嘛，我们刚才说算出来是 0.3 减 0.4J，OK， 所以你的实部小于1，那它的位置会出现在左半边，好，假如大于1的话，会出现在右半边 ，OK。所以实部是 0.3， 虚部嘞，负的 0.4， 哈 ，the imaginary part is minus 0.4. So the top half are positive one, positive imaginary part. The bottom half contains the lines for negative imaginary part, negative imaginary part. So minus 0.4 should be found down below, okay? And as you can see, it's here's the imaginary part of 0. Then you will have 0.1, minus 0.1, minus 0.2, minus 0.3. And this one is minus 0.4. So your corresponding reflection coefficient is located on the intersection of 0.3 real part circle and minus 0.4 imaginary part curve. So the next thing is to determine the reflection coefficient magnitude and phase, which is not explicitly labeled on the Smith chart. 所以反射系数本身并没有办法在史密斯chart上面直接找到反射系数所对应的数字。但是也不难啊，为什么？因为整个史密斯chart就是反射系数的 complex number 的那个图样嘛，对不对？所以你根据它在史密斯chart的相对位置来去决定它的值跟大小嘛。什么样的相对位置？它离圆心的距离，事实上就是它离圆心的距离到 Smith chart 的半径的比例，就是你的 reflection coefficient 的 magnitude 嘛，然后它在这一个全圆里头的夹角，你可以算正负180啦，也可以算0到360都可以，所以以那个点来讲的话，它大致的。应该不会有人把酒拖汤个感觉伊是小于 0.5 吧，所以当然啦，那可以的话，你还是拿尺比一下，好不好？拿尺比比较准啊 ，OK 所以根据它的相对位置，我们就可以看到它的大小大概 0.6， 相角嘞，我要第三象限嘛，它大概是227度了， 考试的时候老师不会跟你太计较这个啦，但是假如这个东西你不要看成是什么0.4，然后正150度，那当然就不行嘛，OK， 它大致在那个区域当然就没问题。好 ，All right. So to enter the reflection coefficient, you just need to find out the normalized impedance, the real imaginary part of the normalized impedance, to find out the location of the reflection coefficient on the Smith chart, and use its relative position to estimate the magnitude and phase of the impedance of the reflection coefficient. So the distance, the ratio of the distance from point A to the center of the circle divided by the radius of the circle is the magnitude of the reflection coefficient, and the angle between the observation point A, with respect to the positive real axis is your phase. If you express this in terms of radian, not degrees, then the reflection coefficient of this point will be 0.6 times exponential j 1.26 pi. All right. Next, you are asked to find the standing wave ratio. 我怎么一下从 ABC 跳到 D 去了 ？OK， 第一步 ，OK， SWR circle. OK, the next thing we are, the next thing we would like to find is the SWR value, and it can be calculated using equation 7.57. That is equals to 1 plus gamma divided by 1 minus gamma, the magnitude of gamma. So because gamma is 0.6 here, that will be 1.6 divided by 0.4. So the standing wave ratio of this point will be 4. No, will be 4. However, you should know how to find it in terms of the Smith chart. Well, equation 7.57 also tells you why the SWR circle can be found on the intersection of the SWR value can be found as the intersection of positive real axis and the SWR circle. Because we know SWR is defined this way, and it corresponding to be the largest input impedance number, not largest input resistance number you can find with this termination. So that will equals to Z sub 0 times the SWR circle, SWR. So we can check up with the, on the right hand, you can check up with the intersection of the SWR circle and the positive real axis. And because on that circle, the distance, for any points on that circle, the distance to the center of the graph is the same. So they all have the same reflection coefficient magnitude. So the reflection coefficient at any point, that is gamma D, gamma at a point position D, shall equals to the reflection coefficient at the determination. All right? And on the Smith chart, we can draw a circle passing through point A with center located at your region. So I recommend it to bring your 圆规的英文怎么讲？突然忘记了。啊，能记得吗？好记得带圆规了再讲一次方便一点啦方便一点。Okay, the circle is known as the constant SWR circle, as I already mentioned, and find out the intersection of the SWR circle with the right hand side of the real axis. And according, for this point, we label point B. And according to the label, according to the ticks on the real axis, the SWR value equals to 4 now, which can be found by knowing the magnitude of the reflection coefficient too. Now, all right, so we starting from point A, we draw the constant SWR circle as shown here, and found the intersection as point B. And according to the label on point B, we know the SWR value is 4. All right, so let's see what can we do next. What do we do next for this problem? And the next task is distance. Find out the distance of the first voltage minimum of the standing wave pattern from the low. That is the D minimum. D minimum. So we know that the termination is located at A, and we know the angle is 227 degrees from the positive real axis. So if we move along the constant SWR circle, you will bump into the negative real axis at the position C, right? So you move along the constant SWR circle, you find the voltage will become larger and smaller, and you will find the minimum voltage at the position C. And the distance to move from point A to point C is the D minimum distance, okay? And how do you determine the distance from A to C? Well, again, you need to use the ruler. So you draw a line from the center O, passing to A, all the way to the outermost circle of your Smith chart. You will find the tick on the outermost circle is labeled as 0.435. So that is your starting point. And if you move along the line, that is moving toward the generator. So you move clockwise, and at the position of 0.5 lambda, 0.5 wavelengths, you will move to point C. That is where you have the minimum voltage. So the distance between point C and point A can be found by subtracting 0.5 with your beginning position 0.435. So the difference is 0.065 is the distance to move from the termination to the voltage minimum. So we can simply calculate the distance from A to C. 那注意啦，还是要把那个线画出去画到最外面，看到最外面那个是最外面那个0到0.5的那一圈是你的，它其实是一个相对位置啦，所以实际要转的那个长度，你要去他们用相加减的方式去算所以假如你的起始点不是 A， 比如说是 F 好了，假如你的起始点是 F 的话，那你要转多远？我要看一下 F 对到的是 0.185， 所以就 0.5 减去 0.185， 那个长度就是 0.315。这个 D minimum 的值一定小于 0.5， OK， 一定小于 0.5 什么时候会到 0.5？ 你在刚好在 C 的外面上面一点点的话，你就要转差不多 0.5 了接近 0.5那也不会是负值啦，所以在做题目的时候小心不要给我一个好笑的答案 All right, so what next? So we find out the D minima is 0.065 lambda. Okay, and here you are asked to find the line impedance at a D equals to 0.05 lambda. So here we are moving in terms of the wavelengths. So it's a small distance, which is smaller than D minimum. So you will move from A to point D. How to do that? You are asked to move on the transmission line for 0.05 lambda. So it's actually equals to 1/10 of a circle. Because one circle is 0.5, you are asked to move just 0.05. So actually you are moving 36 degrees, okay? And to do that, again, you need to check up with your beginning point. Your start position is 0.435. You are asked to move for 0.05. So your start point will be 0.485. So begin from the outermost circle located at the tick of 0.485. Then draw a line from the center to the outermost circle of 0.485. Then find out the intersection of this line with the consonant WR circle. Then it will be your position D. Now that will be the location you move toward the generator by 0.5 wavelengths. What is the impedance of point D? Well, again, you will use the circles on the Smith chart. Okay? So there are some small differences between those circles. You see, the SWR circle doesn't comply with any other circle on the Smith chart. Okay? So at point A, the real part is 0.3. For point D, the real part is a number smaller than 0.3, which you probably won't be able to find the exact circle on the Smith chart. But use inner interpolation 插入法了inner interpolation 内插法用内插法去找一下那个数字你大概可以找到那个数字大概是 0.26 Using inner interpolation method, you can find the real part is 0.26 for position D. The imaginary part, which is also a small number, a small negative number, you follow those curves bending downward. You can see it's about minus 0.09. So the impedance at the position D equals to 0.26 minus J 0.09. Note that this is the so-called normalized impedance, 正规化的阻抗。这是正规化的阻抗。So what is the actual impedance of position D? Well, times the normalized impedance with the characteristic impedance. That will be 50 times 0.26 minus 0.09. Well, you can do that. 所以注意一下的是我们在上面所找到的那些数字都是正规化的电阻、正规化的电抗、正规化的电导、正规化的电纳，都是正规化之后的阻抗跟导纳。所以你要得到真正的阻抗跟导纳的时候，你要注意一下题目问你的是大 Z、大 Y 还是小 z 小 y 啊？等一下有一题那个 Rubio 有一题就这一种的哈，搞清楚。我要问你的是大 ZY 还是小 ZY 哈 ？OK。Alright, so for this case, so you need to turn clockwise toward the generator, and the distance from the load to the first voltage minimum is this 0.065 wavelengths. And if you move just for 0.05 wavelengths, you will end at a point, the intersection, the real and imaginary part of that intersection will be 0.26 minus J 0.09. If you times the characteristic impedance, you can read the actual impedance on that position, on position D, which is 13 ohm minus J 4.5, which is a small number, of course. Okay, the next thing, okay, so here is the procedure that you can do, starting from 0.435, adding 0.05, you end up with this position, and draw a straight line from the center and read out the real part circles and imaginary part circle for the readings of ZD. The next job of equation 7.4 is to find out the 9 admittance at this position at ZD. So what is the relationship between impedance and admittance? Well, the admittance is the inverse of the impedance. Y equals to 1 over Z. So for the normalized admittance, it's also equals to the inverse of normalized impedance. And because we are working on the Smith chart, which draws everything in terms of normalized impedance, we simply find and we already know from last week's lecture that the product of Z and of ZD times ZD plus and minus point写错了。所以答案就是1啦，因为我这边是用那个 normalized impedance 写的 ，normalized impedance 写的。我只要不用 normalized impedance 写的话，应该是这样。那因为 Z0， 因为 normalize 完之后 Z0 就等于1嘛，相当于 Z0 等于1，所以把这边写完。你把那个低点在 Smith chart 上面绕半圈之后，它的值就是会变成原来那一个点的 impedance 的导数。那就等于 YD 了嘛，对不对？所以我们要做的事情就是在 Smith chart 的 SWR circle， 注意是 SWR circle 上面翻到对面去，那个东西从 impedance 的观点来看，就是加减 0.25 个 lambda 的 Z 值。 但你也可以把它看作是 y 值，原来那个低点的 y 值啊，所以导数就在对面，好，所以这第5个 job find out the line admittance at d equal to 0.05 lambda. Actually, the position D. It can be found by moving along the SWR circle to the opposite of it. That is point F in this plot. Point F. Okay. So we're actually moving on the SWR circle to find the, or what you should do is draw a straight line passing through point D, passing through point O, and find out the intersection of the circle with the line on the other end, which is point F. That is the impedance if you move along the constant SWR circle for a quarter wavelength. It also equals to the inverse of the impedance at position D. So what we do is, yeah, I already mentioned that a couple of times. So once you move to the opposite of position D, which can be referred as position E, point E. 我刚刚是不是画错？对不起，写错，不是 F， 是 E。OK， 这一点是 E 啊，点 E 啊。We find out the point E, then we can read out the impedance of point E. That will be 3.4 plus J1.2. Do you know how to do that? To find out the real part, find the intersection of it with full circles. So for point E, here is a small circle, and you can find out its value is 3.4 on the real axis. So that would be the real part of the impedance of point E. And the imaginary part will be a positive number because it is located on the top half of the Smith chart. And it can be found as 1.2. So the impedance at point E is actually the admittance of point D, which is the inverse of the impedance of point D. So every year when I grade the final sheet, I guess about half of the students will just take in the inverse, all right, instead of working on the Smith chart, all right. 好，我知道你们数学都很厉害，计算都很厉害了 ，OK 所以事实上你可以硬干了，对不对？直接算可以了那当然从这边做当然也是可以的所以看到那一个点的话，它所对应到的数字是 3.4 加 1.2J， 不过要注意这是小 y The number you found is the normalized admittance. The actual admittance shall be the product of normalized admittance with characteristic admittance, which is what? Which is 0.02 in this case. 0.02 in this case. So if you time, that is 1/50. So the actual admittance, the capital Y, is 0.06A plus J times 0.024 Siemens. 好，小心看要搞清楚题目问的是Y， 问的是大 Y 还是小 Y 好，那接下来我们看最后一个动作。最后一个动作其实就是在做所谓的 single star matching 所以我们回到题目看看。So the final job is to find out the location nearest to the low at which the real power of the line admittance is equal to the line characteristic admittance. So the interpretation of this question is find out the intersection of the constant SWR circle and the G equal to 1 circle, which can be referred as uniconductance circle。在 Smith chart 上面，所以你现在知道 Smith chart 只要把它翻过去180度，它就是原来是 Z chart 啦。我们一般来看说它是 Z chart， 但是你只要翻过去180度，它就变成是 Y chart。所以翻过去之后，你的 Smith chart 你就要用 admittance 的角度来去看。那还记得那个 single star matching 的那个步骤吗？或者说我们在 single star matching 里头做了什么事情？我们快速复习一下我们之前讲的 single star matching。single star matching 就是我们要接一根 short terminated 的 transmission line， 跟原来的 transmission line 在某个地方接上去。接上去之后，你希望要达到的目的是这边看到的 y 等于1，那你就达到 matching 的地步了嘛，对不对？那为什么要用 short stop？ 因为 short stop 可以给你任意的虚部的电纳，电纳。那在 single star matching 里头，因为它是并联的，所以我们从导纳的角度来看比较方便，所以我们都用 Y。所以在这一个题目里头，它的第一个动作其实就从 Z chart 翻到 Y chart 去，会先翻到 Y chart。然后这一个你知道 short stop 可以创造出任何的 JB 值，所以这个地方只要它的 Y 值，我们这边写 Y prime 好了，等于1减 JB。当然也不一定要是减啦，加的也可以啦。那这边就是它是加的话，这边就是负的。那这两个并联之后，它所看到的 y 数就变成是1了。所以重点在这里，重点在于这个1。你要把这个1帮你决定这个叫做 ds。你要把你的任意的 yd 值在 Smith chart 上面转，沿着什么转？ SWR circle 转，沿着 constant SWR circle 转到它的电导的10步等于1，这样子，不管那个时候的它的导纳的那个电纳值的这个虚部是多少，你都可以用那个 short stop 把它抵消掉。好，所以在Smith chart 上面有一个重要的位置，就是我们刚刚讲的 uniconductance circle。只要你从 Y chart 的角度来看，这一个里面的那一个圈圈有通过原点的圈圈，就是所谓的 uniconductance circle， G 等于1的圈圈。所以，假如你的 SWR circle， 我们用白线画好了，可以跟 G 等于1的 circle 相交的话，那么你只要把它相对应的 G 加 JB 把它相对的 B 值抵消掉，你就可以跑到 matching 的位置，把虚部抵消掉，那它是不是就会落到圆心的地方？好，所以用 Smith chart 来去对传输线做 阻抗匹配需要做到的事情是，让你的 Smith chart 你的传输线的阻抗值或导纳值能够落到 Smith chart 的圆心，也就是 reflection coefficient 等于0 ，SWR 等于1的位置。好，所以 OK, so go back to the problem. In the sixth part, item 6, you are asked to find out the intersection of your point and you need to find out the position for intersection of uniadmittance, uniconductance circle. So the first thing is moving from point A to point F. Moving from point A to point F. Because point F, you can find out the corresponding admittance of your termination. So you see, for point A, the reference location on the transmission line is 0.435. If you add it up by 0.25 and subtract with 0.5, you will end up with 0.185. That will be F, your F point. So you are still on the constant SWR circle. You didn't move anywhere. But if you move to the opposite of your SWR circle, then you are moving from, you are jump from Z chart into Y chart. 所以我们这边做了一个跳跃啊，那是时空的跳跃嘛，也不是时间，也不是空间的，反正它就从 Z chart 跳到 Y chart， 就在对面啊。所以这边我们先从 A 到 F， 我们并没有真的让它移动干嘛的，只是我们让它跳到对面，那我们就从导纳 Y 的角度来去处理这个问题啊。所以 F 点的值，事实上也就是 A 点的导纳值。所以你可以去看一下 F 点的那个实部虚部是多少，它的实部应该略大于1嘛，对不对？你会看到它离 G 等于1 circle 还蛮近的，然后它的虚部会是 1.3、1.4 之类的，当然你说老师我不可以把 Point A 的那个阻抗值直接取导数，对啊，也可以啦，当然对了啊。好了，那题目问的是什么？题目问的是说从 F 点出发，毕竟你现在是 load 的 admittance， 我靠，我还想说我讲的太快了，没有，结果 OK， 好了，那就明天再继续。好了，我把这段讲完好，那我们 Ruby 就明天再用好了 ，OK， 好 ，Ruby 明天再用好了。所以 F 点要接下来要到哪里？找到它跟 G 等于1的交点，然后他这边问的是找到最近的那个交点，请问是要往哪边走？它只能往顺时针方向走了，事实上它有2个解，一个解在 G。一个解在上面，可是它只能顺时针转，所以最近的解在这里，你不要给我画到上面去逆时针转，那没办法，你转不过去了但你把这个点再转 0.2， 不是 0.25 个 lambda 不止，再多转一点的话，你事实上还有一个解会有2个解。那这个解 G 点的话呢，它就是它的那个时虚部位等于多少？1减负 1.4 之类的，所以假如你能够用那个 show stop 造出一个正 1.4 的话，在那边跟它并联，你就可以得到 matching。好，我们今天到这边。